Hello and welcome to Algebra 2 tutorial. Today we're starting with quadratics. And what we're going to be first looking at is how to take the basic quadratic function, the parent function, and transform it in 2 or 3 different ways. And so we've looked at this parent function before, but we're going to take one more look at it right now. The basic quadratic function y equals x squared. And we'll draw a quick graph of that so we can see it, but hopefully it all looks familiar to us. So, y equals x squared. Let's do a quick table here, I suppose, of x and y. So we'll put 0 in there. So of course if x is 0, y is also 0. If x is 1, 1 squared also gives us 1. If x is 2, we square it, we get 4. I suppose if I do the negatives as well, they of course become positive, but they are the same values. Negative 2 squared is positive 4. And if we start graphing this, we get something that is fairly familiar. A point there. At 1, we are also at 1. At 2, we're up to 4. And we are starting to get that popular parabola shape, which is a U. If we kept going, 3 squared brings us up to 9, all the way up here, and its partner point on the other side, and there is our parabola shape. So that's what we're going to be working with for a while now. This is the most basic, the parent function, and we are going to be transforming it, which means we're going to move it up and down and left and right. That's a translation. And then we'll be flipping it over the x-axis like this. That's a reflection. And we will also be stretching and shrinking it. So that's really what we're going to take a look at here. So let's get started on that. So our transformations are next. There's 3 ways we want to tackle this. If you're given a description, if you're given an equation, or if you're given a graph. And you want to be able to move between all 3 of those. So if you're given 1, the equation, you should be able to describe it verbally and draw a graph as a visual. And same thing for the other 2. So let's start with the equation. That's usually what we get. But then we're going to turn that into a description and a graph. So here we have an equation. Y equals 2 times the quantity of x minus 3 squared minus 7. So we remember what all of these parts do, a, h, and k. Just like with the absolute value equations, h moves us side to side, k moves us up and down, and a stretches and shrinks, and it also controls the reflection. So first thing I see here is there's a 2 in front, so we have a stretch by a factor of 2. Stretch by a factor of 2. So this parabola is going to get taller, which essentially makes it look skinnier. All right, and then a minus 3 where h is. So that means we're going to be moving to the right 3. That's the tricky one. You have to remember that that does the opposite of what it looks like. If you see a minus, that means you are moving to the right. So we call that a translation. So we are translating right 3 and the minus 7 at the end, that's the k, that controls the up and down. Nothing weird about that one, so a minus sends us down 7. So there we have a description of everything that is happening to this parent function, the parabola shape. So let's draw a graph of that now so we can actually get a visual. So I would first maybe do the translation. We are going to the right 3, 1, 2, 3, and down 7. So 5, 6, 7. So right here is the vertex of the parabola. And in order to stretch by a factor of 2, this parabola is going to be a little bit skinnier. Now, depending on how accurate you want to be, you could just draw the parabola shape nice and skinny here. There is sort of a pattern you can follow here. A parabola usually goes 1 over 1 up, 1 over 2 up, or sorry, 3 up, and then 1 over 5 up. And you can just double that. So we're going to go over 1 up 2. And then instead of over 1 up 3, we're going to go up 6. 1, 2, 3, 4, 5, 6 to there. And then over 1, instead of up 5, we would go up 10. So that would put us up at 11. And then you can just draw the partner points. There, there, and there. And we have our parabola. You don't necessarily need to know that shortcut for getting all the points, but this parabola is just slightly skinnier and taller, you could say, than usual. All right, so we took our equation, and we made a description, and we made a graph. Time to go the other directions. So we took the equation and made the other two. Let's take a description now and turn that into an equation and a graph. So we're going to take the parent function y equals x squared, and we're going to reflect it over the x-axis and translate it left 4 and up 8. So our equation, y equals... So in order to reflect it over the x-axis, we need a negative in front. If we're going to go left 4 units, on the inside, we're going to have a plus 4. All right, that sends us to the left. It's a little counterintuitive, but that's the way the inside works. Don't forget your squared that makes a parabola. And in order to go up 8, the k value has to be plus 8. So we took that description and turned it into an equation. All right, now time for the graph. Let's draw a quick sketch of that. So we are moving to the left 4 and then up 8. So right here is where the vertex is going to be. We were reflected over the x-axis, so the parabola, instead of going up, it is now going to be going down. All right, so instead of going, my points going up, they're going to go down. So I'm going to go over 1, down 1, over 1, down 3, and then down 1, 2, 3, 4, 5. We don't have any stretch. So this follows the basic pattern. So there is our parabola. There we go. So we took a description, we turned it into an equation and a graph. We've got one more combination to do here. If we're given a graph, can we turn that into a description and an equation? So let's do that one. So here we have our graph. First, let's describe what happens. So the first thing I see here is the parabola is upside down. So the parent function has been reflected over the x-axis. It's been flipped over the x-axis. So the parent function I'll even name it y equals x squared, was reflected over the x-axis. Now, what else happened? Then, so that would take my parabola that was facing up, and if we reflect it over the x-axis, it would be facing down. But it's not over here, it's over here. So then it was translated 1, 2, 3 to the left, and then up 2. So this vertex was moved 3 to the left, and then up 2. I'm sure we call that a translation. Then translated. Three left, and up 2. All right, we have our description. We described the transformation that we saw here. Now let's write the equation. So we were reflected over the x-axis, so that means there's a negative in front. We were translated 3 to the left, so that will be x plus 3 on the inside. Remember, it's a plus because we are going to the left. That's a little counterintuitive. Square it, that gives us our parabola, and then we were moved up 2, so plus 2. Now I should mention that there is no stretch here. I made this one a simple one, but you can check. We did go over 1, down 1, over 1, down 1, 2, 3. So there is no stretch here. That is sometimes hard to see from a graph, and so hopefully you're not on the hook to do that too much. But you can sometimes check it by counting to see if there's an easy stretch or no stretch at all. All right. We've done all 3 combinations now. We were able to look at the parent function, y equals x squared, which is a basic parabola. And then we transformed it in a couple of ways, and you want to make sure you can do all 3 categories here. A verbal description, a numeric equation, and a visual for a graph. So here's a few practice ones for you to try. See if you can do those, and if you can, you've got this down pretty well.